Hey there, fellow builders and creators. When we talk about engineering, we're talking about bringing ideas to life. But before we can build anything, we need a plan, a blueprint. And that's where dimensions and tolerances come in. They're the language of engineering drawings, telling us exactly how big or small something should be. Dimensions are those numbers on a drawing that tell us the exact size of something, like the length, width, or height. Tolerances, on the other hand, are like little safety nets. They tell us how much wiggle room we have, how much a dimension can vary from the ideal number and still work perfectly. Imagine you're baking a cake. The recipe gives you dimensions, like using 1 cup of flour. Tolerances are like saying you can be a little over or under, maybe a tablespoon or 2, and your cake will still be delicious. In the world of engineering, tolerances are crucial because we can't make things perfectly. Every manufacturing process has tiny variations. Tolerances ensure that even with these tiny variations, our parts will fit together and our machines will work smoothly. Now let's talk about tolerance stack-up. Imagine you're building a tower out of blocks. Each block represents a part in our design, and each block has a tiny bit of size variation. What happens as you stack more and more blocks? Those tiny variations start to add up. That's tolerance stack-up. It's what happens when the allowed variations in individual parts accumulate, potentially causing problems in the final assembly. Think about a simple object like a retractable pen. It might have a dozen parts, each with its own tolerance. If some parts are slightly larger and others slightly smaller than their ideal sizes, the pen might not retract smoothly, or even worse, jam completely. Tolerance stack-up is a chain reaction of sorts. The more dimensions you have in a chain, the greater the chance for those tolerances to stack up and cause headaches. Remember those blueprints we talked about? Well, just like a bad recipe can ruin a cake, poor dimensioning on a blueprint can lead to all sorts of engineering disasters. One common mistake is over-dimensioning. It's like giving too many instructions. If you tell someone to go north for 1 mile, then turn right and go east for 1 mile, you've given them the same information twice. It's redundant and can lead to confusion. Another common pitfall is chain dimensioning. This is when we create a chain of dimensions, one after another, to define the overall size of something. The problem is that any error in one dimension gets carried over and amplified down the chain. The solution to these dimensioning dilemmas is baseline dimensioning. Instead of chaining dimensions together, we establish a single, reliable baseline and reference all other dimensions to that baseline. It's like using a single, accurate ruler to measure everything instead of relying on a bunch of mismatched sticks. Section 4. Avoiding tolerance. Troubles. Best practices for dimensioning success. So, how do we avoid these dimensioning disasters and keep our tolerance stack up in check? It all comes down to following some simple best practices. 1. Keep it simple. Keep it clear. Just like a good recipe, our dimensions should be clear, concise, and easy to understand. 2. Baseline is king. Embrace baseline dimensioning. It's like having a strong foundation for our design. 3. Datum delight. Datums are fixed reference points on our parts. Think of them as the starting line for all our measurements. Using datums consistently ensures that everyone is on the same page. 4. Tolerance teamwork. When selecting tolerances, we need to consider the capabilities of our manufacturing processes. Tighter tolerances mean more precise manufacturing, which can sometimes mean higher costs. It's all about finding the right balance. By following these best practices, we can ensure that our designs are clear, our parts fit together seamlessly, and our creations work exactly as intended. Section 5. The big picture. Why good dimensioning matters. In the grand scheme of things, good dimensioning practices are about more than just avoiding tolerance stack-up. They're about ensuring quality, saving time and money, and building a better future. When designs are clear and tolerances are well defined, manufacturing becomes more efficient, waste is reduced, and products are more reliable. This means happier customers, a healthier bottom line, and a more sustainable future for everyone. So, let's make a pact to embrace the power of good dimensioning. It's a small step that can make a world of difference.